Okay, whether my voice is clear to everyone? Yes or no?
Yes, sir.
Hello, whether my voice is clear to everyone? Can you please give me the reply whether my voice is clear?
Yes, sir, audible.
Yes or no? Okay, whether PPTs are visible?
Yes, sir.
Whether you are able to see the PPT on your screen? Okay, now we'll start. So in the last lecture, we have completed our chapter number 2, that is nothing but the multi-pressure system. So in continuation with chapter number 1, our chapter number 2 was there, because in chapter number 1 we have covered related to the vapor compression refrigeration system, whereas in case of multi-pressure system, same VCRS system, when we are using two or more than two compressor or two or more than two evaporator, that is called as a multi-pressure system. So now after chapter number 1 and chapter number 2, we are going to start our chapter number 3, that is nothing but refrigerant. So the syllabus for this chapter, so this is a completely theoretical chapter. So the syllabus for this chapter is nothing but, first of all, what is meant by, or first is nothing but classification of refrigerant, then whatever various types of refrigerants are there. So we are going to see what are the desirable properties of those refrigerant, then how to give the nomenclature for various type of refrigerant. Then next point will be selection of refrigerant for particular application. Then next point will be the secondary refrigerant. Then we have to see the what is the effect of ozone depletion on global warming, as well as on the what is the effect of refrigerant on ozone depletion as well as on the global warming. Then we are going to see the concept called as a total equivalent warming impact, that is also called as a TEWI. And last point is nothing but the alternative refrigerant. And I think number of hours allocated for this chapter by university is nothing but, I think 2 or 3 hours will be allocated for this chapter. So this is completely theoretical chapter. So assignment for this chapter, that is nothing but assignment number 3. So whatever PPTs I have shared, I have shared the PPTs on your mail as well as on your WhatsApp group also. So there assignment number 1 and assignment number 2 are there. So you can start the writing of assignment number 1 as well as assignment number 2 on notebook as well as on the pages which whatever is available with you. So for assignment number 3, first question is nothing but define primary refrigerant and classify primary refrigerant. Then explain any two in detail. So whatever various types of primary refrigerants are there, out of that primary refrigerant we have to explain any two in detail. Then second point is nothing but explain designation system for halocarbon refrigerant. Explain designation system for halocarbon refrigerant, and we have to find out the chemical formula for R12 and R123. So R22 and R123. So whatever those R22 and R123 is there, so that is called as a nomenclature of that refrigerant. The next point is enumerate desirable properties of refrigerant. Fourth question is explain the effect of CFC on ozone depletion. And last question is nothing but classify secondary refrigerant and explain any one in detail. So now we are going to start our chapter. So as the name of chapter is nothing but a refrigerant. So what do you understand from the name called as a refrigerant? What do you think? What is meant by refrigerant? So we have seen the vapor compression refrigeration system as well as air refrigeration system, that is Bell-Coleman refrigeration system, reverse Carnot refrigeration system. After that we have seen the multi-pressure system. So in each and every system, we were using the word called as a refrigerant. What is the meaning of refrigerant? You can tell me what is the meaning of refrigerant? Anyone? कशाला म्हणतोय आपण refrigerant? Will tell me.
Sir, working medium used in this system.
Vasange.
Yes, sir. Working medium used in this system.
What is the meaning of refrigerant? कशाला म्हणणार आहे आपण refrigerant? अमित खाडे. Working fluid. Okay. So we are knowing that in any of the refrigeration system, there what we are doing, or what that working fluid is doing, that working fluid is absorbing the heat inside the evaporator, and whatever heat is being absorbed by that refrigerant inside the evaporator, same heat is being rejected inside the condenser. So refrigerant, okay. Sorry, whether my voice is clear to everyone? I was not able to hear you because my audio was off. Now you can tell me what is by refrigerant. Can anyone tell me? Vasange?
Yes, sir.
Okay, what is by refrigerant?
Whatever working medium used in this system is known as refrigerant.
Okay, so refrigerant is nothing but working medium which is used in the refrigeration system, which was absorbing the heat from the substance which we want to cool inside the evaporator, and that heat which is being absorbed by that working substance, that is being rejected inside the condenser. So whatever that heat absorption and heat rejection process was there, that was because of change in temperature or change in phase. That means we are knowing that in case of evaporator, that liquid refrigerant is getting converted into vapor refrigerant by absorbing the heat, and inside the condenser, that vapor refrigerant is getting converted into liquid refrigerant by rejecting the heat. So the proper definition of refrigerant is nothing but refrigerant is a substance, or that is also called as a working medium or working fluid, which is used for transfer of heat in the refrigerating system from the low temperature region to the high temperature region. And whatever this transfer of heat from low temperature region to high temperature region is taking place, that is mainly taking place because of changing the phase of that refrigerant or by changing the temperature of that refrigerant. Because we are knowing that in case of evaporator, that means inlet of evaporator is nothing but outlet of your expansion wall. So at the outlet of expansion wall, that refrigeration system will have the low pressure liquid vapor mixture. So whenever that low pressure liquid vapor mixture will be passed through the evaporating coil, so surrounding to that evaporating coil, whatever substances are there which is being cooled or which we have to cool, so which is the heat which is being involved in that various substances, that heat will be absorbed by that working fluid, and because of the same, that substances will be cooled. So whatever heat is being absorbed by that working substance, that heat is used for conversion of the phase of that refrigerant from liquid vapor mixture to the vapor. So here refrigerant is nothing but the working substance or working medium or a fluid which is used for transfer of heat in a refrigeration system from the low temperature region to the high temperature region by changing its phase or by changing its temperature. Now find the word by changing its phase or by changing its temperature, and or word is there here. If you see, so here if you see, changing its phase or oblique and by changing its temperature. Why the word is or and or oblique and? Because if you see, in case of air refrigeration system, in case of air refrigeration system, that means our reverse Carnot cycle as well as Bell Coleman cycle as well as the refrigeration system which is used for aircraft refrigeration, there we were using the air as a refrigerant. So whenever we are using air as a refrigerant, that air was not changing its phase. In that case, only sensible heat was absorbed in case of air refrigeration system. But if you see the vapor compression refrigeration system, if you observe the vapor compression refrigeration system, so in that vapor compression refrigeration system, liquid or saturated liquid was getting converted into superheated vapor. That means in that case, sensible as well as latent heat is being absorbed by that refrigerant. So you have to always keep in mind that in case of air refrigeration system, the refrigerant is only absorbing the sensible heat, whereas in case of vapor compression refrigeration system, that refrigerant is absorbing the sensible as well as latent heat. So there are various applications of that refrigeration system. So depending upon the various application, or depending upon the various application, or depending upon the suitability, uh, various refrigerants are used in various conditions. So suitability, so depend upon various properties, refrigerants are being used for the various application. Now next point is nothing but what is meant by our classification of refrigerant. So in the market there are various or n number of refrigerants are available. So all those n numbers of refrigerants are categorized mainly into two types. First one is called as a primary refrigerant. Second one is called as a secondary refrigerant. So what is meant by primary refrigerant? What is meant by primary refrigerant? So if you consider the our domestic refrigerator or the fridge which is available in our house. So in that fridge there will be the refrigerant gas. So that refrigerant gas is passing from the compressor to the condenser, condenser to the expansion wall to the evaporating coil, and evaporating coil to the again compressor. So evaporating coil will be placed inside the freezer. So whatever substances which we are keeping inside the freezer, so that refrigerant is directly absorbing the heat from the substances which we want to cool. So those refrigerant will be called as a primary refrigerant. So primary refrigerant is nothing but refrigerants which directly take part, or the refrigerants which are directly absorbing the heat from the substances which we want to cool. That will be called as a primary refrigerant. Whereas secondary refrigerant. So if you take the example of air conditioning system, or another example as a ice manufacturing industry. So in case of ice manufacturing industry, so whatever ice cube we are producing, so surrounding to that ice cube, we are having the brine solution. So that brine solution is absorbing the heat from the water which is kept inside the ice cube, and because of heat absorption, that ice water is getting converted into ice. But whatever heat is being absorbed by that brine solution, same heat will be absorbed by the primary refrigerant. So secondary refrigerant is nothing but the refrigerant which are being cooled, or those are firstly cooled by the primary refrigerant, and then those refrigerants will be used for cooling purpose. Those will be called as a secondary refrigerant. Or if you take the another example as a central air conditioning plant. So in case of central air conditioning plant, we are having the air handling unit, that is also called as a AHU. So what we are doing? So whatever air we are cooling, suppose we are in the need of 20 degree centigrade air. So that air will be cooled with the help of chilled water. That air will be cooled with the help of chilled water, which will have the temperature as a 10 degree centigrade or 15 degree centigrade. But for producing of chilled water, we are using the primary refrigerant. So whatever chilled water we are using for cooling of the air, that will be called as a secondary refrigerant. So secondary refrigerant is nothing but the refrigerant which are first cooled by the primary refrigerant and then used for cooling purpose are known as a secondary refrigerant. So whatever primary refrigerants are there, those primary refrigerants will be classified into four categories. Out of that, first one will be called as a halocarbon refrigerant. First one will be called as a halocarbon refrigerant. Second one will be called as the azeotropy refrigerant. Then third one will be called as the inorganic refrigerant. And last one is called as a hydrocarbon refrigerant. So this is the classification of primary refrigerant. And whatever secondary refrigerants are there, those secondary refrigerant will be basically categorized into two categories. First one will be called as water and second one will be called as a brine solution. Whereas brine solution is nothing but the mixture of water and salt or mixture of water and glycol. There you may use as a ethyl glycol or propylene glycol, or in case of salt you can use as a NaCl or CaCl2. So that will be called as a brine solution. So whatever this slide you are observing, this is nothing but the complete classification of a refrigerant. So for understanding purpose, you have to always keep in mind that all the refrigerants are categorized mainly basically into two categories. First one as a primary refrigerant, second one as a secondary refrigerant. Then primary refrigerants are categorized into four categories. First one halocarbon refrigerant, second one azeotropy refrigerant, third one inorganic refrigerant, and last one is nothing but hydrocarbon refrigerant. And whatever secondary refrigerants are there, those are categorized as a water or, and second one is nothing but brine solution. So whatever may be the refrigerant which is available in the market, that will fall under one of its category. So this is nothing but the classification of refrigerant. Now we have to see one by one all the types of refrigerant. So first of all, we will see primary refrigerant. So I have already told you the definition of primary refrigerant. What is the definition of primary refrigerant? The refrigerants which are directly taking part in the refrigeration system, that is called as a primary refrigerant, or these are the refrigerants which cool the substance or space directly by absorbing the heat. That may be latent heat or that may be latent as well as sensible heat. That may be latent or that may be latent as well as sensible heat. When that latent heat will be absorbed, whenever there is a change of phase of that refrigerant, that is liquid refrigerant is getting converted into vapor refrigerant, or vapor refrigerant is getting converted into liquid refrigerant, then there will be the change of, or there will be the absorption or rejection of latent heat. But whenever there is a change of phase as well as change of temperature, then there will be the absorption as well as rejection of latent as well as sensible heat. So this is the definition of primary refrigerant. Then primary refrigerants absorb the heat during the evaporation in the evaporator, and those will reject the heat during the condenser or during the condensation in the condenser, that I have already mentioned. Then secondary refrigerant. So secondary refrigerant are nothing but the refrigerant which are first cooled by the primary refrigerant and then used for cooling purpose. So in refrigeration plant, a secondary refrigerant is used as a cooling medium which absorb the heat from the refrigerated space and transferred to primary refrigerant in the evaporator. So the meaning is same. Now whatever classification of primary refrigerant is there, so we will see one by one all the type of refrigerant. So out of that, first type of refrigerant is nothing but halocarbon refrigerant. Now here, if you see the word or the name of this refrigerant, what is the name of refrigerant? Halocarbon refrigerant. Halocarbon refrigerant. Out of that, first word is nothing but halo. So that word halo came from the word called as a halogen or halogen group. Halogen group. So as we are knowing that whatever chlorine or fluorine or bromine, whatever fluorine or bromine atoms are there, those are coming under the category called as a halogen. And second word is nothing but the carbon. So in the refrigerant or in any of the refrigerant, if along with carbon, either fluorine or bromine, or there may be the chances that chlorine or bromine, or combination of chlorine and fluorine, or combination of chlorine and bromine. So if in the if in the chemical formula of that refrigerant is containing carbon along with any of the halogen atom, or two or more than two halogen atom, there may be the chances that there is carbon, chlorine, fluorine. There may be the chances that there is, along with carbon, there is a chlorine as well as bromine. So if along with carbon halogen atom is present, then such type of refrigerant will fall under the category of halocarbon refrigerant. Then such type of refrigerant will fall under the category of halocarbon refrigerant. So how to identify? I have told you, if in the chemical formula along with carbon, if in the chemical formula of refrigerant along with carbon, if halogen atom is present, halogen means either chlorine or fluorine or bromine, then that refrigerant will fall under the category of halocarbon refrigerant. So ASHRAE, what is the long form of ASHRAE? American Society of Heating, Refrigeration and Air Conditioning Engineering. So that ASHRAE has identified total 42 refrigerant which are coming under the category of halocarbon refrigerant. But out of those 42 refrigerant, only few of them are commonly used refrigerant. So ASHRAE has identified total 42 compound as a halocarbon refrigerant. So all the halocarbon refrigerant are synthetically produced, and those are also called as a freon group of refrigerant. So halocarbon refrigerant is also called as a freon group of refrigerant. Those are also called as a freon group of refrigerant because there is a this is nothing but the halogen family. So freon, that is also called as a halocarbon refrigerant. Freon group of refrigerant is also called as a halocarbon refrigerant. So as I told, or as I have mentioned, that it includes refrigerants which contain one or more of the three halogen. One or more of the three halogen. That means either chlorine, fluorine, and bromine. One or more of the three halogen along with carbon. That will be called as a halocarbon refrigerant. So in the market, whatever those halocarbon type of refrigerants are there, whatever halocarbon type of refrigerants are there, those are available under the trade name of freon, genetron, or isotron or arctron. So in the market, those refrigerants are sold under the trade name of, where is that, genetron, isotron, and arctron. So those are the market name of halocarbon refrigerant. As I mentioned you, this complete chapter is a theoretical chapter. So you need to study this chapter. So, and this is very much simple chapter. Once you read this notes, you will get easily. But you have to remember all the points. Then whatever applications of halocarbon refrigerants are there. So all the halocarbon refrigerants are used for domestic, commercial, as well as industrial purposes. And there are some advantages as well as some disadvantages of those halocarbon refrigerant as compared to other family of refrigerant or other categories of refrigerant. Now I will show you some of the commonly used refrigerant which are coming under the halocarbon refrigerant. So first refrigerant is called as a R11 refrigerant. First refrigerant is called as a R11 refrigerant. The chemical name of that R11 is nothing but trichloro monofluoro methane, trichloro monochloromethane, and whatever chemical formula of that R11 is there, that is called as a CCl3F. So whatever this chemical name is there, that chemical name is derived from the chemical formula. So here, if you see the chemical formula of R11, what is the chemical formula of R11? CCl3F. So as only one carbon atom is there here, if you see CCl3F, so along with carbon there is a chlorine as well as fluorine. So if along with carbon chlorine, fluorine or bromine will be present, that will be called as a halocarbon refrigerant. So here one carbon, 3 chlorine and 1 fluorine is present. So here as one carbon is there, so it will be the family of methane. In chemistry we have studied that if in the chemical formula, if one carbon is present, that will be called as a methane. If two carbon will be present, that will be called as ethane. If 3 carbon will be present, that will be called as a propane. If 4 carbon will be present, then that will be called as a butane. So methane, ethane, propane and butane. So here as only one carbon atom is present, so this will be the family of methane. How many chlorine atoms are present? 3 chlorine atoms are present. And how many fluorine atoms are present? 1 fluorine atom is present. So first of all, as 3 chlorine atom is present, that's why trichloro. As 3 chlorine atoms are present, that's why trichloro. As only 1 fluorine atom is present, that's why monochloro. Here MONO word is there, not I. Monochloro, and 1 carbon atom is present, that's why it is a group of methane. So first of all, you have to consider the number of chlorine atom, then number of fluorine or bromine atom, and after that how many number of carbon atoms are there. Depending upon that, you have to identify the group of that carbon. So here trichloro monochloromethane. Second refrigerant is nothing but R12. You might have heard the name as a R12 किंवा R22 पण ऐकलं असेल. That is the refrigerant. So the chemical formula of R12 is nothing but CCl2F2. CCl2F2. Here if you see the chemical formula, in this chemical formula, 1 carbon atom is present, 2 chlorine atom is present and 2 fluorine atom is present. If 1 fluorine or fluorine atom will be present, that will be called as a monochloro or monofluoro. If 2 chlorine or fluorine atom will be present, that will be called as a dichloro or difluoro. If 3 atom will be present, that will be called as a trichloro or trifluoro. If 4 atom will be present, that will be called as a tetrachloro or tetrafluoro. So here as 2 chlorine atom is present, so while giving the chemical name, first of all you have to consider number of chlorine atoms. So dichloro. First word will be dichloro. Second word is nothing but number of fluorine atom. How many number of fluorine atoms are there? 2 fluorine atom. So dichloro, difluoro. Then number of carbon atom. As 1 carbon atom is present, that's why it will be the group of methane. If 2 carbon atom will be present, that will be the group of ethane. 3 carbon atom, that will be the group of propane, and 4 carbon atom will indicate the group of butane. So here dichloro, difluoro, methane. Then next refrigerant or next commonly used refrigerant is nothing but R13. Chemical formula of R13 is nothing but CClF3. CClF3. In all those chemical formulas, you will be able to observe the carbon along with halogen group. Halogen group means chlorine, fluorine, bromine. या तिन्हीपैकी एक किंवा दोन असतील किंवा तिन्ही पण असू शकतील along with carbon. That will be called as a halocarbon refrigerant. So as the chemical formula is CCl3F3. So 1 chlorine, that's why monochloro. Then 3 fluorine, that's why trifluoro. and one carbon, that's why methane. Monochloro trifluoro methane, that will be the chemical name of refrigerant called as a R13. Then you might have heard the name as a R21, R22 as a refrigerant. So out of that, R21 is nothing but CHCl2F. CHCl2F. Whatever first three refrigerant were there. Wait for 1 minute. Whatever first three, that is R11, R12 and R13. R11, R12 and R13. If you see the chemical formulas of R11, R12 and R13, you will observe that there is only chlorine, fluorine and carbon. So this will be called as a CFC family. CFC group of refrigerant. CFC means chlorofluorocarbon refrigerant. This will be called as this three refrigerant will be called as a CFC refrigerant. Why CFC? CFC is indicating chlorofluorocarbon refrigerant. So here only chlorine, fluorine and carbon atom is present. That's why those will be called as a CFC type of refrigerant. Now whatever R21 refrigerant is there, the chemical formula of R21 is nothing but CHCl2F2. Here along with carbon, chlorine and fluorine, there is a hydrogen atom. There is a hydrogen atom. That's why this type of refrigerant will be called as a HCFC refrigerant. HCFC refrigerant. Hydrochlorofluorocarbon. HCFC means hydrochlorofluorocarbon type of refrigerant. So here, because why there is a hydrogen atom? Because we are knowing that any of the carbon atom, any carbon atom will have the 4 valency. Any carbon atom will have the 4 valency. So out of that 4 valency, if 2 valency is filled by the fluorine atom, if 2 valency is filled by the fluorine atom, 1 valency is filled by the fluorine atom, then whatever remaining vacant valency will be there, that will be filled with the help of hydrogen atom. That will be filled with the help of hydrogen atom. That's why it will be called as a CHCl2F. That is nothing but dichloro. Here also, while reading the name, first of all, number of chlorine atom, dichloro, number of fluorine atom, monofluoro, and how many carbon atoms are present? 1 carbon atom. That's why it will be the methane group. So dichloro, monofluoro, methane. That is nothing but R21. Then R22. Formula is nothing but CHClF2. The chemical name will be monochloro difluoromethane. Monochloro difluoromethane. That is nothing but R22. So those two refrigerant will fall under the category of HCFC type of refrigerant. That is also called as a hydrochlorofluorocarbon refrigerant. Then next refrigerant is nothing but R30, R40. Next refrigerant which are coming under the category of halocarbon refrigerant is nothing but R30 and R40. So here if you see R30, so chemical formula of R30 is nothing but CH2Cl2. So the chemical name of this will be methylene chloride, CH2Cl2. In chemistry, in 12th science or 11 or 12th science, you are knowing that there is a methylene or ethylene group. So CH2Cl2, that will be the methylene chloride, and R40 is nothing but CH3Cl. CH3Cl, that will be called as a methyl chloride. That will be the chemical name of R40. Then whatever next refrigerant number is there, that is called as a R100. So R100 chemical name is, or chemical formula is nothing but CH3CH2Cl. Here, now if you see number of carbon atom in this formula, how many carbon atoms are there? This is the first carbon atom. This is the second carbon atom. So as two carbon atoms are present, that's why this will be the group of ethane. This will be the group of ethane. So here you will see that this is the group of ethane. So this will be called as a ethyl chloride, CH3Cl2Cl, that will be called as a ethyl chloride. Then next chemical refrigerant number is nothing but R113. Chemical formula is nothing but C2F3Cl3, that is also called as a trifluoroethane. As two carbon atoms are present, that's why it will be the group of ethane. Then 114, R114. So formula is nothing but CF2Cl, CF2Cl. Now here if you see number of carbon atom, this is the first carbon, this is the second carbon. So number of carbon atom is nothing but 2. How many chlorine atoms are present? This is the first chlorine atom, this is the second chlorine atom. So as two chlorine atoms are present, that's why this will be called as a dichloro. It will be called as a dichloro. How many fluorine atoms are present? These are nothing but two fluorine atoms, and these are nothing but another two fluorine atoms. So four fluorine atoms are present, that's why tetrafluoro. So you can name this as a dichloro tetrafluoro. And number of carbon atom is nothing but 2, that's why ethane. So it can be read as a tetrafluorodichloro or dichloro-tetrafluoro. Both the names are correct. You can also say call it as a dichloro-tetrafluoroethane. Then here R114A. R114A. So why that A name is given? Because it is the isotope of the same formula. So while giving the or while studying the nomenclature system of halocarbon refrigerant, you will be able to understand how those chemical formulas are coming based on the refrigerant number, or based on chemical formulae, how you are able to find out the chemical or refrigerant number. So in the next lecture we are going to see that nomenclature system. There you will be able to identify the type of refrigerant or the refrigerant number based on the chemical formula, or chemical formula based on the refrigerant number, both way. Then R115, that is also called as a CClF2CF3, that is also called as a difluoroethane. Now out of those all the refrigerant which are coming under the category of halocarbon refrigerant, the most commonly used refrigerant are nothing but R11, R12 and R22 refrigerant. So these are the three refrigerants which are most commonly used for domestic purposes, commercial purposes, as well as industrial purposes. So we'll see the properties of those refrigerant. So before seeing the properties of any specific refrigerant, first of all we will see the properties of commonly or common properties of halocarbon refrigerant. First of all we'll see the common properties of halocarbon refrigerant. So whatever halocarbon refrigerants are there, all the halocarbon refrigerants are non-toxic in nature, those are non-flammable, those are non-explosive, non-corrosive and non-irritant to human body and eyes. So first is nothing but non-toxic. So those are not in the toxic nature. Non-flammable. So those refrigerant whenever will be mixed with the air, those will not be form a flame, or those will not be the flammable in nature or explosive in nature. Those will not be non-corrosive whenever the refrigerant will come in contact with the metal, and those refrigerant will be non-irritant to human body as well as eyes. So this is the first common property which is applicable for all the type of halocarbon refrigerant. Then second common property related to halocarbon refrigerant is nothing but all the refrigerants are odorless as well as colorless. So those refrigerant will not have the specific color. All the type of refrigerant which are coming under the halocarbon category will not have the specific color as well as specific odor. So those will be called as the odorless as well as colorless. Then next one is nothing but all the refrigerant will not react with the food which is being stored in the refrigeration system. Whenever any leakage of a refrigerant will takes place, and because of leakage, if those refrigerant will come in contact with the stored food in that refrigerated space, then whatever halocarbon refrigerants are there, those will not react with the food which is being stored in the refrigerated space. Then those halocarbon refrigerant will not react with the lubricating oil. That is the next common properties of halocarbon refrigerant. So where those refrigerant will come in contact with the lubricating oil, because we are knowing that in case of compressor, because in case of Fisher system compressor is present. So in case of compressor there are number of moving parts. So proper functioning of number of moving parts as well as to reduce the friction, there we are using the lubricating oil. So inside the compressor that refrigerant is coming. So whenever that refrigerant is coming inside the compressor, that refrigerant will come in contact with the lubricating oil. So if there will be any type of reaction of that refrigerant along with a lubricating oil, then property of that refrigerant will goes on decreasing. So we have to select the refrigerant which will not react with the lubricating oil. So halocarbon refrigerant, all the halocarbon refrigerants are not reacting with the, or those are not forming any chemical bond with the lubricating oil. Then next common property is nothing but all the halocarbon refrigerants are having excellent thermodynamic properties. So we are going to, or we are also going to see the desirable properties of all the refrigerant. So whatever properties of refrigerants are there, so those are categorized basically into three categories. First one is nothing but the thermodynamic property. Second one is nothing but the physical property of refrigerant, and third one is called as the chemical property, as well as those are also called as the safe working property of the refrigerant. So whatever halocarbon refrigerants are there, those are excellent thermodynamic properties. And the last point related to halocarbon refrigerant, common point, that is nothing but all the halocarbon refrigerant are affecting on the ozone layer. So that is the only disadvantage of the halocarbon refrigerant. And this disadvantage is such a bigger that nowadays not a single halocarbon refrigerant we are using for domestic purpose as well as commercial purposes. So halocarbon refrigerants are being banned by the government in all the countries. So in the phase out period only nowadays we are using R22 refrigerant. Rest of all the refrigerants are being banned because of those, as those the refrigerant is consisting of the carbon, chlorine and hydrogen. So those are affecting on the global warming as well as ozone depletion that we are going to see afterwards. That means in the same chapter. So this is the biggest disadvantage of all the halocarbon type of refrigerant. So example of halocarbon refrigerant is nothing but CFC refrigerant, HCFC refrigerant and HFC refrigerant. Out of that CFC, I have told you the long form of CFC. What is the long form of CFC? Chlorofluorocarbon. Chlorofluorocarbon. So out of halocarbon refrigerant R11, R12, R13, then R113, R114, R115. If you see the chemical formulas of this refrigerant, so in the chemical formulas of this refrigerant, you will only find the carbon, fluorine and chlorine. Carbon, fluorine and fluorine. That's why those will be called as the CFC type of refrigerant. Then next one is nothing but the HCFC type of refrigerant. HCFC type of refrigerant. What is the meaning of HCFC? Hydrochlorofluorocarbon type of refrigerant. So if you see the refrigerant number R21, R22, R123, so in those refrigerant you will find that there is a hydrogen, chlorine, fluorine and carbon. That's why those will be called as a HCFC type of refrigerant. That is also called as a hydrochlorofluorocarbon refrigerant. And last one is nothing but HFC type of refrigerant. HFC type of refrigerant, that is called as a hydrofluorocarbon refrigerant. Hydrofluorocarbon refrigerant. So if you see the refrigerant number R134A, R404A, R407C, R410A, those are the type which are falling under the HFC refrigerant, hydrofluorocarbon refrigerant. So those are the various categories of halocarbon refrigerant. As now time is 4 o'clock, so we are going to end our lecture here. So you are now you can write the your roll number in the chat box, and you can join the next lecture. Next lecture will be of OR lecture.